Okay, so we got simple probabilities. And then we had what we called OR probabilities. We'll just call them an OR problem. And when we had OR problems, we applied what we called the OR formula. So the probability, hey Peyton, I don't think you're muted. If you could mute that, thank you. The OR formula went like this: the probability of the first event, the probability of A, plus the probability of the second event, the probability of B, minus the probability of A and B. So it's been a little while since we've done that, but that should look familiar. And then we had what we called AND probabilities. And for that, we applied this formula: the probability of A and B is equal to the probability of A times the probability of B, assuming that A has occurred. All right, and then we had problems that said, that began with the question, how many? So these were different in nature, the how many problems, because they weren't asking about probability. How many ways can such and such occur? So on those problems, we ask a couple of questions. The first question we ask is repetition allowed? And if the answer to that question is yes, repetition is allowed, then we drew blanks. And just to see, if you remember from days gone by, let me ask this question to the class. Do you remember the second question we asked if the answer to repetition allowed was no?
Does order matter?
That's right, it was does order matter? Good, okay. So, does order matter? Question mark. And of course, that could be answered yes or no. And if it was yes, we used a permutation. And if it was no, we used a combination. And normally on this test, I'll put in at least one question, but I think this time we'll forego an at least one question. We'll just major on the majors, so we won't even worry about that. Good morning to Juliet and Cheyenne. I see that you have joined us.
Good morning.
Well, so really, we're just going to practice some problems. We're just going to see which one of these four type of problems we have, and then we'll apply the appropriate formula or the appropriate line of questioning. Hey, Savannah, what are you drinking there?
Coffee.
Yeah, well, I've got, I went with double sweetener and French vanilla creamer today. What do you do?
It's like Dunkin' Donuts creamer.
Dunkin' Donuts creamer, that sounds good.
Mm-hmm.
Yummy. Well, okay, so now I gotta find the notes that I made to myself. about where those problems are, and where are the notes that I made to myself? Well, let me look here. I'll get on board here in just a second. Okay, there they are. So it's actually page 311 that I want you to turn to. And we'll pick some problems off of that page to help us practice a little bit. What if I did that? That might be better yet. The closer I get, the better it focuses too. Okay, that's a good idea. Class, that was Kaylee yawning. If you get contagious yawns, it started with Kaylee and Donovan Bow. I guess contagious isn't a very good word to use right now, is it? Oh, Peyton, we have a guest with us today. Who do we have with us?
This is Piper.
Piper. What is Piper?
She is a Shih Tzu.
Is that right? Well, hello to Piper. Okay. I had some cats in my class yesterday. Today's the first time ever in 29 years I've had a dog in my class. Interesting. Well, hello to Piper. Okay, so it says here that the first problem that we want to look at is number 10, which actually isn't any one of those four that I put up. It's just a simple computation problem. So a little calculator practice on number 10. So you may have a little bit of calculator practice on your test, like maybe a permutation or a combination or maybe something like this. This problem, you just kind of punch it in just like it reads. I think you would be fine. Although to be extra careful, you could put the parentheses around the numerator. So we got to remember where the factorial is. So let's see here. The combinations and the permutations of the factorial, do you remember they're all in this math menu? It's math and prob, and number 4 is your factorial. And don't forget what I keep telling you about, if you forget where something's at, you can always go to the catalog and you can find it there. So what was that? 6 factorial times 2 factorial. And then we're going to divide by 4 factorial. So hopefully when you punched all that in, you ended up at 60. Hey, how many of those you want on your test? I mean, that's good living, right? It's pretty good stuff there. Okay, so let's jump next over to, I've got number 12 circled. It's just another little calculator problem. So once you work out in front of me and try a combination of 9 things 4 at a time, and make sure that you get 126 when you do that. Okay, so the key sequence there would have been 9, math, stupid calculator. So it should look like that to get your 126. Pretty straightforward. Let's jump down to a problem like number 17 next. So we've got, in a survey of 500 randomly selected Americans, It was determined that 22 play soccer. What is the probability that a randomly selected American plays soccer? So, class, ask yourself, do you think this is a simple probability problem, an or problem, an and problem? It's not a how many problem because it doesn't say how many. So, give me hand raises on how many of you think it's a simple probability problem. Remember, I probably can't see your hand raise unless you use the electronic hand raise. So go to reactions. Oh, I didn't mean hand raise. I meant clap or thumbs up. One of those. Okay, so we've got a few giving me, several of you giving me simple probability problems. Okay, how many of you think it's an or problem? Don't see any. How many of you think it's an and problem? Okay, so let's go with the simple probability. That's what I'm seeing here is the most common choice, and it is the right choice, by the way. So in this case, it's just an empirical probability. The probability that a randomly selected American plays soccer is the number who played soccer, 22, out of the total in our sample, which is 500. And you could either reduce that or give it to me as a decimal. And as a decimal, that's 0.044. So you could see something that straightforward on your test. That's pretty simple. Okay, everybody good? Okay, good. Getting some few thumbs up there. Good. Okay. All right, let's jump next down to number 22. So if you don't have your book in front of you, what 22's got to offer here. According to the Statistical Abstract of the United States, about 17% of all 18 to 25-year-olds are current marijuana users. What is the probability that 4 randomly selected 18 to 25-year-olds are all marijuana users? Okay, so let's stop and talk about something for a moment. At first glance, this looks like it might be a binomial probability because either you're a marijuana user or you're not. Okay, but remember, to have a binomial probability, you have to have a fixed number of trials in an experiment, and we don't have a fixed number of trials here. We're just talking about the population at large. So it's not that. So let's look at part A here. It says, what is the probability that 4 randomly selected 18 to 25-year-olds are all marijuana users? So it's probability. So it's going to be one of these 3. Okay. It's not just a simple probability because we're not just asking about one thing. We're asking about 4 things. So really, you have to boil this down to either an or problem or an and problem. So when it says, what is the probability that 4 randomly selected 18 to 25-year-olds are marijuana users, does that mean we'd be looking for the probability that the first is a marijuana user or the second is a marijuana user or the third or the fourth? Or would that be, be looking for the probability that the first is a marijuana user and the second is a marijuana user and the third and the fourth? What do you got there, class? Shoot me some chats as to what you think it would be. I'm getting ands all over the house, and you ands are correct. Good, it's going to be an and problem. Okay, so since it's an and problem, then we need to apply this formula, and this formula says to multiply the probabilities. So in other words, we would be looking for the probability that the first is a marijuana user and the second is a marijuana user and the third is a marijuana user, and the fourth is a marijuana user. Now applying the formula that we just had then, that would equal the probability that the first one uses marijuana times the probability that the second uses marijuana, given that the first used marijuana, times the probability that the third used marijuana, given that the second and the first used marijuana. I'll just put the second. Times the probability that the fourth used marijuana, given that the first three used marijuana. I'll just put the third. Okay, let's pause here and see if I got any hand raises or if I got any questions. Everybody seems to be doing okay. Okay. So the probability of any one of those using marijuana, according to this data, is 17%. So this is 0.17, and this is 0.17. The probability that the second used marijuana, given that the first used marijuana, doesn't really change. It's still 17%. All four of these will be 0.17. So if we take 0.17 and raise it to the fourth power, I get this number. Now write down on your paper what you think this number is, and then I'm going to show you what I think it is, and let's see if we agree. So I would really be looking for one of a couple answers here. Remember, your calculator has converted to scientific notation here, so you could put 8.35 times 10 to the negative 4, and that would be fine. Or you could just move the decimal 4 places to the left, which would give you 0.000835, and that would be fine. What I don't really want to see is this, because that doesn't really mean anything to a mathematician. That's just a funky way that your calculator has decided to write this number. All right, let's pause and breathe for a moment. Hey, we've got another guest in our class. Who do we have with us, Kaylee?
This is my sister, Aubrey.
Hi, Aubrey.
She's kind of
Well, it's kind of fun to get to meet your all's dogs and families and stuff. Okay, so what am I doing here? Is that all of 22? No, there's a part B. Okay, let's go to part B. See what it says. What is the probability that among the 4 randomly selected 18 to 25-year-olds, at least one is a marijuana user? That's an at least one problem, and I told you we wouldn't worry about those on this test given our unusual circumstances, so don't worry about 22B. Okay, let's go to number 23. Here we go. Sean is planning for college and takes the SAT test. While registering for the test, he is allowed to select 3 schools to which the scores will be sent at no cost. If there are 12 colleges he is considering, how many different ways could he fill out the score report form. Okay, you ask yourself if we have a simple probability, an or problem, an and problem, or how many problem. This one should be screaming at you that it's a how many problem. Okay, so we've got to think through our list of questions here. So first, let's see if repetition is allowed. And by the way, I don't remember, so I got to reread. And usually it takes me 2 or 3 reads of a problem, of a how many problem to get to where I need to go, and really a probability problem too. So what do we got here? We got 12 schools. I'm picking 3 to send my score to. How many different ways can I fill out the score report form? Okay. So right now on my screen, I see Jenna, Kaylee, Savannah, Peyton, and Cheyenne. So my question to you all is repetition allowed here?
No.
Real loud, Savannah. I don't think we heard you.
No.
Okay, and why do you think not?
Because, like, if he gets into one college, he can't get into it again.
Right. Peyton, what are you thinking?
Yeah, I was thinking the same thing. You can't go list the same college twice on that list.
Okay, that's correct. So let's stick with you 5. So we've answered that question, no. So now we're going to answer this question. Does order matter? And so the way I encouraged you all to help you answer that question is just list out a possibility. So if I sent my score to Yale, then Duke, I think I almost got to throw up here, Duke, and then Harvard, is that the same as Duke, then Yale, then Harvard in the context of this problem?
Yes.
Yes. Okay. So since you're saying yes, does that mean order matters or it doesn't matter?
It does matter.
Say that again.
It does matter. Yes, it does.
Okay. Savannah, Kaylee, and Jenna, do you agree with that? Kaylee, you're giving me a little bit of a funny look there.
I don't think
No,
it
I
does.
don't think it
because
does.
Yeah, I don't think order matters.
Okay. Tell me why you don't think order matters.
I mean,
Could it be the same either way?
it's the same.
Okay. It'd be the same either way here. If I send it to Yale, then Duke, then Harvard, that'd be the same as sending it to Duke, then Yale, then Harvard, right? The same 3 schools are getting the scores either way. So this would actually be a combination, and I'm choosing, what was it, from 12, and I'm choosing 3. Is that what it was? 12, 3? Yes, 12, 3. That's what it was. So a combination of 12 things 3 at a time. So let's see what we end up with there. See if my calculator turns off when I hit enter this time. No. Woo-hoo. How about 220, class? Everybody good with that? The next problem I have to look at is the next problem, number 24. Let's see who shows up on my screen now. I've got Heidi, Grayson, Tommy, Rebecca, and Lauren, and Jaden. So we'll get you guys involved here in a moment. Number 24 says, the distribution of National Honor Society members among the students at a local high school is shown in the table. A student's name is drawn at random. So what do we got? 92 seniors and 37 of those are NHS members. 112 juniors, 30 of those are NHS members. Why aren't freshmen NHS members? Well, I was the NHS sponsor back in the day at Scott City High School, and you had to earn a bunch of points before you could even be considered. Is that the way it was at your high school for like Beta Club or NHS or whatever? So you couldn't get in until you were a sophomore anyway. Part A says, what is the probability that the student is a junior? If we select a student's name at random. So Heidi, Grayson, Tommy, Rebecca, Lauren, or Jaden, do we have a simple probability problem here, an and problem, or an or problem?
I think it's simple.
I agree with that.
Okay, we got two simples.
I agree. It's simple.
You are correct. It is a simple probability. And usually if it's simple probability, it's only asking about one thing, right? What's the probability that the student is a junior? So what do we got here? 112 juniors out of how many ever students total? I don't know what that adds up to. It's going to be 112 out of this total. So let's let our calculator do the work here. 112 divided by 92 plus 112 plus 125 plus 120. So I'm looking at 0.249. Okay, now let's go to part B. Now I'm about to make myself out to be a not right person. Because part B says, what is the probability that the student is a senior? And look at the next two words. Given that the student is in the National Honor Society. So let's write that out, what that just said. Probability that the student is a senior, given that they're in NHS. Now here's why I made myself out to be incorrect. Because technically this does not fit any of these four categories. The only place we see a conditional probability is at the end of our AND formula. Okay, so this is like the end of your AND problem because it's a conditional probability. They gave us a given that or some condition. So remember what that means is we're limiting our sample space to the NHS students only. I'm not considering any of the other students, only the NHS students. So if I do that, if I limit myself to the NHS students, then I'm limiting myself to these 37 plus 30 is 67 plus 20 is 87 students. And then 37 of those are seniors. So how about 37 out of 87? Which is approximately 0.425. So you might see one conditional probability. If you want to make a separate category in your little chart to help you with that, you can. Or you can just remember when you see that given that, we're talking about a problem that would be like this end part of the AND formula. All right, let's scroll through you all. Of course, some of you, I can't see your faces, so I can't tell if you're going like this or if you're going like this. So maybe next time you'll join with video, and that'd be wonderful. Okay, well, I've kind of scanned through everybody there. The next number I picked out to look at is 26. That's the problem that says test twist. Never heard. Or does it say text twist? Didn't know there was such a thing. In the game of text twist, 6 letters are given, and the player must form words of varying lengths using the letters provided. Suppose that the letters in a particular game are E, N, H, S, I, C. A, how many different arrangements are possible using all 6 letters? I pause and give you a moment to think. Okay, hopefully what you're thinking is that's a how many problem, and you're asking if repetition is allowed. Well, what is it in this problem that tells me that repetition is not allowed? We're using all 6 letters. Okay, and then the second question is, does order matter? And this problem says how many arrangements. So if I had E-N-H-S-I-C, that's a different arrangement than if I had N-E-H-S-I-C. So order does matter, so this would be a permutation. And I'm choosing from 6, and I'm choosing all 6. So punch in a permutation 6, 6, and see if you get this 720 or not. 6 math permutation 6 is 720. Okay, let's go to part B. That's part A. You guys read part B ahead of me, and then get you an answer, and then I'll follow up with you. We'll see if you're right or not. See if I'm right or not. Hey, there's Mackenzie and Juliet. Well, on 26B, it's a very similar question. Repetition's not allowed, again. And order still matters because we're still asking about arrangements. So the only thing that's different here is we're picking from 6 things, but we're only picking 4. So it'd be a permutation 6 things 4 at a time. So a 6 math permutation 4 is 360. Okay. So we got part A. Part B wasn't too bad. Let me read part C and make sure that we want to do it or not. The solution to this game has 3 6-letter words. To advance to the next round, the player needs at least one of the 6-letter words. If the player simply guesses, what is the probability that he or she will get one of the 6-letter words on their first 3 guesses of 6 letters? Okay, let's not worry about part C. Okay, that was an at least one question, and it was going to get pretty convoluted. Look at something right quick. Okay. Okay, so I think we're about done with that page, but there's still, I don't think we ever got to an OR problem. So we need to get to an OR problem. So flip over to page 315. Okay, let's look at number 13 together. Here we're talking about the game of roulette. A wheel consists of 38 slots numbered 0, 00, and 1 through 36. To play the game, a metal ball is spun around the wheel and allowed to fall into one of the numbered slots. The slots numbered 0 to 00 are green. The odd numbers are red, and the green numbers are black. A, determine the probability that the metal ball falls into a green slot. Okay, that's just asked me about one thing. The probability of a green slot. So this is just simple probability on part A. And it said 0 and 00 are green, so that's going to be 2 slots out of 36, which would reduce to 1 out of 18. Which would be fine, or you could give me a decimal like 0.056. So part A is no big deal. Let's go to part B. Determine the probability that the ball falls into a green or a red slot. So this is screaming OR at us. Okay, and a lot of times when it's an OR problem, you're just going to see the word OR. So if it's an OR problem, then let's apply the OR formula. So you go ahead and apply the OR formula here and work out in front of me a step, and I'll catch up to you and we'll see if you're applying it properly. Hey, Lauren, shoot me a chat and tell me if your microphone is working today or not, or you could just answer if it is. Okay, got it. Okay, so on this problemo, we would have gone probability of the first plus probability of the second minus the probability of both. So the probability that the ball would fall into green is what we just figured here, 2 out of 36. Hey, Mr. Black, why don't you put 1 out of 18? Well, I'll show you why here in just a moment. And then red, I don't remember how many slots for red. Somebody remind me how many slots for red.
$18.
That's right, because there were 38 total and 2 were green. So that leaves 36, and half of those are red, half of those were green. Good, yeah, 18 out of 36. Hey, class, how many slots were both green and red?
$20.
No, it doesn't say green or red. It says how many slots were both green and red.
None of them.
2.
No, it didn't say how many were green. It says how many were green and red.
0.
There you go. Zilch. Zilcheroni. Okay. So, and I heard some of the rest of you say 0. So you were correct. So what we got here? 20 out of 36. It'd be 10 out of 18 or 5 out of 9. That's 0.56. If you convert that to a decimal, that'd be fine. Okay, so that's an or problem. Now, it won't always be the case that when you get this and part back here, that's going to be 0. For example, if I ask you a card problem, if I said, what's the probability of getting a king or a heart? If you draw a card from a 52 card deck, well, that'd be probability of king plus probability of heart minus the probability of getting both a card that is king and heart. And of course, there are 4 kings, so the probability of getting a king is 4 out of 52. Hey, Rebecca, Mackenzie, or Juliet, do you remember how many hearts there are?
No.
Okay, that's an acceptable answer. Hey, Savannah, do you remember how many hearts there are?
There are 13.
There are 13 hearts. That's right. 13 out of 52 minus class. What's the probability of getting a card that is both king and heart? So I have to think about how many cards are kings and hearts at the same time. And that'd be 1, right? There's 1 king of hearts. Mackenzie, you got a thought?
No.
A little bit louder, Mackenzie. I didn't quite hear you there. I still didn't hear you. I tell you what, Mackenzie, shoot me a chat because your audio is breaking up. So shoot me a little chat and I can take your question that way. Oh, gotcha. Very good. Okay, so 4 and 13 is 17. 17 minus 1 is 16 out of 52. And if you reduce that, that's 4 out of 13. So listen, there's a good chance you could see some card problems on your test. So make sure you're familiar with a deck of cards. I don't want you to miss the problem because you're not familiar with a deck of cards. If you get in the middle of your test and you forget some details about a deck of cards, then shoot me a chat or raise your hand or whatever, and I'll show you a deck. But you probably want to be somewhat familiar with it before you even start. So remember, on page 271, there's a deck of cards there shown for you. So if you want to just kind of refamiliarize yourself, remember there are 4 suits: spades, hearts, clubs, and diamonds. They each have 13 cards, ace through 10, and then jack, queen, and king. So that's 13 cards in each suit. That's where Savannah got her 13 hearts a while ago. And then half of the cards are red, so 26 of them are red. Half of them are black, so 26 of them are black. And the jack, queen, and king in each suit are face cards. So there are 3, 6, 9, 12 face cards total. 6 black face cards and 6 red face cards. So again, that's page 271 if you need to go back and brush up on that a little bit. But again, if you get in the middle of the test and you don't remember the details related to a deck of cards, raise your hand. You know what? That's probably, I'm wrong. I can't show you a deck of cards because you're going to have your email up on your screen. So I won't be able to show you a deck of cards. So make sure you're familiar with a deck of cards. Okay, let me check my other notes here. So if we need to keep going here relative to this. Okay, let's look at number 14 right quick. And I want to look at part D on 14. So that's this question right here, but it's tied to the problem at the bottom of the previous column. So go ahead and read number 14 to yourself. So it says in 2009, there were 33,722 traffic fatalities in the United States. Of these, 9,817 were alcohol related. And part D says, what is the problem? What is the probability that neither of two randomly selected traffic fatalities in 2009 were alcohol related? Okay, so I wanted to look at this problem because it didn't ask the question in the same way the other problems had. The other problem we had like this would have asked, what's the probability that both of them were alcohol related? This one says, what's the probability that neither of them were alcohol related? Okay, so this is going to be an and problem, because I'm not saying what's probability that the first is not alcohol related or the second. I'm asking the probability that the first is not alcohol related and the second is not alcohol related. So it'd be like this: probability that the first one is not alcohol related and the second is not alcohol related. I don't know why I put NR, but I did. Okay, now that I've established it as an and problem, let's apply the and formula. So that'd be the probability of the first times the probability of the second, given that the first occurred. Okay, now here's the tricky part. Again, we're not looking for the probability that this was alcohol related. We're looking for the probability that it wasn't alcohol related. So out of those 33,722, 9,817 were alcohol related. So 33,722 minus 9,817 were not alcohol related. So 23,905. So you don't always just want to take the numbers that are given to you in the problem and just start throwing them into your formula. You got to think about what it's asking for. Now, what are we going to do? We're going to assume that that one was not alcohol related and find the probability that this is not alcohol related, which means now we're down to 33,721 accidents, of which 23,904 would have not been alcohol related. So listen, I think if you punch this in just like it's written here, I think you'll be fine. But I'm always leery with fractions of doing that. So if I was you, I would put parentheses in these two positions when I punch my first fraction in, and parentheses in these two positions when I punch my second one in. So punch that in, and my book says that's approximately 0.503 So punch that in, see if you get 0.503. And if you do, give me some kind of indicator, like a thumbs up or something. And if you don't, make sure you let me know that, and we can look at that. Okay, good. Thank you. There's a couple showing up. Another one. Okay. Okay, so is everybody golden on 0.503? All right, let me check this one last problem that I had mentioned to myself. I think we're okay on that. It's just like that. So really, we did one of every single kind, at least. The only thing we didn't do is a how many problem where repetition is allowed, and then we would just draw in blanks. Okay, so everybody unmute yourselves for a second and tell me if that makes you feel better or worse about the chapter 5 part. Dick, what?
Feel
Give me
better
some.
about it.
That's one person. Keep going, everybody.
Better.
A little better.
Better.
Thank you.
Definitely better.
Oh, I
Better. I'm feeling a
can
lot
hear
better
your
about it.
voices. That's nice. Okay, here's your review assignment. Don't consider yourself ready for this test until you've done this assignment, checked it in the back, and got it right. Let's go with 12 through 15 on page 315, 17 through 22, 24 through 26, but on number 26, only do parts A and D, and number 30. And then we'll break it right here. And when we come back, I'm gonna make myself a note here to record so I don't forget like last time. And when we come back, we'll dig in on chapter 6. So taking 5, I'm gonna pause the recording. Is what I wanted to do. Yeah, there it is. Okay. For the chapter 6 part of the review, let's flip over to page, where is it? 354. All right, let's look at, first of all, problem number 2. Now listen, class, I always put number 2 on this test, and somebody will miss it usually, and there's no reason for any of you to miss this problem, okay? Don't miss. If you're going to miss something on this test, don't miss number 2. Determine whether the distribution is a discrete probability distribution. Remember, we're just looking at, are all these individual probabilities 0 to 1 inclusive? So in other words, we don't want to see a negative, or we don't want to see something bigger than 1. And do they all add up to 1? I don't know, let's add them. We can do that almost in our head. 0.34 and 0.21 is 0.55, and 0.13 is 0.68. 0.04 is 0.72, and 0.01 is 0.7. I didn't get these to add up to 1. Did you, class? Okay, so it says if not, state why. So your reason why here is all the probabilities do not sum to 1. Okay, so you'll see something like that on your test. So that's pretty nice. Let's take a look at number 3. The Stanley Cup is a best-of-7 series to determine the champion of the National Hockey League. The following data represent the number of games played, X, in the Stanley Cup before a champion was determined from 1939 to 2011. There was no champion in 2005. The season was canceled due to a labor dispute. I wonder what the books of the future are going to say about 2020, if there was a champion in 2020. Good question. Hey, Tommy, I've got a coffee cup just about like that. Believe it or not.
Stole it from my daughter. I haven't done my dishes in days.
Well, hey, it's all good. So we're supposed to create a frequency distribution. Now, if this was your test, I probably would have already given you the frequency distribution, but let's go ahead and create it here on this problem. So it says X is the number of games played. Now, this makes sense if you think about it. It's a best of 7 series, so it's the first team to win 4. So if one team wins all 4 of the first 4 games, then the series is over, right? There's no reason to play games 5, 6, and 7. And so X is a variable because it can change. The number of times that 4 wins or 4 games were played was 20. I'm just recreating the chart right now. 5 was 17, 6 was 19, and 7 was 16. That's interesting if you're a sports fan that the most frequent occurrence is a sweep in hockey. Now, a frequency distribution, the part I'd probably give you on your test, would have the probability of each of those outcomes. So here the probability would be 20 out of the total number of finals. Or I don't know. Has somebody added up the frequency column yet?
$72.
70 exactly?
2.
72, okay. So that's going to be 20 out of 72, which means 5 games is going to be 17 out of 72, which means 6 games would be 19 out of 72, which means 7 games would be 16 out of 72. And we would probably want to reduce those fractions here, or we could do decimals. So let's say we did decimals. 20 out of 72. Let's go to 3 places. 0.278. $17 out of 72 is 0.236. 19 out of 72 is 0.264. And 16 out of 72 is 0.222. So really, the probability of any one of those number of games occurring are pretty close. They're all about equally likely outcomes. So I'm not a gambler, and I'm not encouraging you to do this necessarily, but if you are a gambler, you can bet on all kinds of things, like what's the over-under on a 7-game series in the Stanley Cup Finals. And if they set it at 5, you know, maybe you could make your bet there. A little bit more than half the time you have 5 games or less. So that'd be almost a pick 'em bet, pretty close. Okay, so let's go to we've done part A, construct a probability model. Part B says draw a probability histogram. I'm not all that concerned about that. Let's go to part C and part D. Compute and interpret the mean of the random variable X in part C. Compute the standard deviation of the random variable X on part D. Okay. So this is the part I wanted to get to, and this is the part that you'll see on your test. How do you find the mean and the standard deviation from a probability distribution? Well, all we did was we stuck our outcomes in list 1, the associated probabilities in list 2, and then we did variable stats list 1, comma, list 2. So why don't you all set about the business of that, and I'll do the same thing here. So hopefully your data in your list looks something like what I've got showing. Okay, and then from your home screen, like I said, we're going to stat, and then calc, and variable stats. We have to tell the calculator where our data list is. It's in list 1. And we have to tell it where the frequencies are, and playing the role of frequencies here are probabilities. That's in list 2. So that means on average, there are 5.43 games that are played in the Stanley Cup final with a standard deviation of 1.16. So a typical deviation from that is about 1 game. So in other words, we'd expect a lot of our data values from be like 4, 5, and 6. Okay, questions? All right, moving on down the road then. Okay, and then that's going to bring us to the binomial probability problems like we had due for today from chapter 6, section 2. So the problems we're getting ready to work should be similar in nature to the problems you worked in your homework. Let's work together, page 356, number 6. Okay, so we have on that page, let's take a look here, the probability that a randomly selected patient who visits the emergency room will die within 1 year of the visit is 0.05. Let's not do that problem right now. Let's do number 7. It's just, you can do number 6 for homework later. We'll do number 7. Okay. According to a Gallup poll, 60% of U.S. women 18 years old or older stated that the minimum driving age should be 18. And a random sample of 15 U.S. women 18 years old or older find the probability that exactly 10 believe that the minimum driving age should be 18. That's interesting. 6 out of 10 women over the age of 18 think the driving age should be 18 or older. Well, I got to be honest. When I was trying to help my daughter learn to drive when she had her permit when she was 15, I was amazed at how little she knew. And my daughter's halfway intelligent individual, and wow, it was scary at first. And like she would, never mind, long story. So anyway, okay. You're going to have to be able to recognize when you have a binomial probability problem. And I told you to focus mainly on one thing. Are there only two possible results? But on that earlier problem, we also saw that we have to have a fixed number of trials. And so do you see that on this problem, we're talking about a sample of 15 US women? Okay, we have a fixed number. And either they believe that the driving age should be raised to 18 or they think it should stay where it's at. So only two possible results, success or failure. Okay. On part A, we're looking for the probability that exactly 10 believe the driving age should be 18. So we're looking for the probability of 10. So last time, we said that if you've got a binomial probability problem, it's either going to be a binom PDF problem or it's going to be a binom CDF problem. It's going to be one of those two, and for both of them, we punch in the N, then the P, then the X. So let's go out there. I don't know who I've talked to and who I haven't. Let's just go to the bottom. Cheyenne, Jaden, Juliet, Lauren, Rebecca, and Mackenzie. Which one of those two is this problem, and how do you know? Okay, if you're not sure, shake your head no. Okay, so, okay, let's go. Let's give you all then, let's throw in with you Grayson and Jenna. Do either one of you two know which one of these two it is? Okay, I'm getting no response there. Okay, Tommy or Peyton, do either one of you two know which one of these it is? Heidi, Savannah, or Kaylee?
Would it be a PDF?
Okay, Savannah, it is PDF. You are right. Now tell the class how you determine in your head which one it is.
Because with a PDF, you're looking for an exact number. And in this case, we're looking for exactly 10 people.
Good. And then what does CDF do?
It's like counting down, like 3, 2, 1 or 2, 1, 0. It's not just one exact number.
Yeah, so CDF would be if we wanted 10 and 9 and 8 and 7 and 6 and 5 and 4 and 3 and 2 and 1. It'd be if we wanted all those added together. PDF is exactly a number, just like she said. Okay, so that's how you know the difference. So use this one when you're looking for one value or exactly the probability of exactly one value. Use this one when you want to add that value plus all the previous values. So here on this problem, we're going to binom PDF. Don't forget that that's in the distribution menu. So second distribution. So it's the letter A on my calculator, probably is on yours as well. And we had 15 in our sample, so that's our N, comma. P is the probability of success on any trial, which this problem says 60% of women believe that the driving age should be raised. So that's next, comma, and then the number that you're looking for. We're looking for the probability of exactly 10. That's your X, 10 successes. Class, how about 0.1859? Kaylee, I'm getting the look again. Hang on.
I was just concentrating.
Say that again. I still had you muted. I'm sorry.
I'm good. I was just concentrating.
Okay, gotcha. Everybody else good? Hand raises or anything? No hand raises yet. Thumbs up from Jaden. Okay, very good. Okay, let's go to part B. Where'd it go? Part B says find the probability that fewer than 5 believe the minimum driving age should be 18. Okay. Well, you got to think about what fewer than 5 means. So here's what I suggested the other day. Could fewer than 5 mean 6? No. Could fewer than 5 mean 5, class? Is 5 fewer than 5? No. Could it be 4 or 3 or 2 or 1 or 0? Yes, it could. It could be any of those. So here, fewer than 5 would mean all the way up through 4. So I want to add all those together. So this is a binom CDF problem. I want to add up through 4. So here we're going to binom CDF. I've still got 15 in my sample. My probability of success is still 0.6. But I want to add up through 4. Okay, so here we go. Binom CDF, 15, comma, 0.6, comma, 4. 0.0093, class. All right, there's part B. Now let's do part C, which is also like some of the homework problems I gave you. Let's take a look at it. It says find the probability that at least 5 believe the minimum driving age should be 18. Okay, at least 5. So I asked myself, could at least 5 be 4? No, 4 is not at least 5. Could at least 5 be 5? Yes. Could it be 6 or 7 or 8 or 9? Yes, all the way up through 15. So this means add up from 5 all the way through 15. So I could do that, but that'd be a lot of work, wouldn't it? I'd have to find the probability of each one of those individually and then add them up. Or wouldn't from 5 all the way up through 15 be the complement of 0 through 4? So I could just take 1 minus the answer that I got on the last problem. That would take out the possibilities of 0 through 4, leave me with 5 through 15. So I should be good by going 1 minus 0.0093. 0.9907. Okay, so and again, what we just applied there is the complements rule. 5 through 15, 5 or more, is the complement of less than 5. Okay, and then let's look at part D. It says find the probability that between 7 and 12 inclusive believe that the minimum driving age should be 18. So the way that we wrote that last time was like this. We wrote that 7 is less than or equal to x is less than or equal to 12. In other words, the number could be anywhere from 7 to 12, which would mean I could take probability of 7 plus probability of 8 plus probability of 9 plus probability of 10 plus probability of 11 plus probability of 12. If I do that, that's 6 different problems. Okay, so let's do it that way first. So Kaylee and Savannah, we're gonna do something a little different here. You all are gonna do the probability of 7. I want you to send a private chat to one another and check your answers with each other. Okay, Heidi and Peyton, you're gonna do 8. Let's see, Tommy and Grayson, you're going to do 9. Jenna and Mackenzie are going to do 10. Rebecca and Lauren are going to do 11. And then Juliet and Jaden are going to be 12. And Cheyenne, it looks like I got an odd number of people here, so I guess you can just pick whichever one you want, and then don't worry about chatting because you can only chat to one person privately. Okay, does everybody see what we're after here? Get your answer, check it with your chat person. By the way, all of these are individual probabilities. You're not adding up through the number. You're just looking for the probability of the number. So these should all be PDF problems that you're doing here. Okay, so Savannah and Kaylee, have you all checked with each other yet? Okay, and do you agree with each other?
Yes.
Okay, so what do you get for the probability of 7? Give me about 4 decimal places.
0.1181.
Okay. Heidi and Peyton, have you all agreed or not at this point?
We're still working on it.
Okay, that's all right.
I haven't sent a message yet.
Okay, all right, we'll come back to you. Tommy and Grayson, have you all agreed with each other?
Yes.
Okay, and what number did you get for 9?
0.2066.
Did you say 0.2026? 0.2066, okay. Very good. Who's next? That'd be Jenna and Mackenzie. How about the two of you?
I haven't checked yet.
Okay, we'll come back to you. Rebecca and Lauren, have you checked?
Yeah.
Okay, and what number did you get for 11?
0.1267.
Okay. And then Juliet and Heidi. Who did I put Juliet? Hey, Juliet, who did I put you with? I don't know. Did I put you with Heidi? Jaden. Okay, Juliet, you're, sounds like you're, say something again because I think your audio might not be working. Try it again. Yeah, I think maybe your microphone's not picking you up. Did you guys check with each other yet? Okay, Jaden, do you have the number for 12? Yeah, I'll take that as a no. Let's circle back to 8. Is the number for 8 done now?
Yes, we got 0.11 or 0.1771.
1771, good. Is the number for 10 done now?
Yeah, 0.185.
I think you said 0.1859. If that's wrong, send me a chat and I'll correct it. Okay, and then last call on 12. Maybe I can knock that one out here real quick. Let's see here. Find on PDF, we're choosing from 15, we're using 0.6, and we're doing 12, and I got 0.0634. Okay, so there are all 6 of those probabilities individually. Now, if I add those together, we should be at the promised land. Has anybody added these together yet? If not, let's just crank it right out. 0.1181 plus 0.1771 plus 0.2066 plus 0.1859 plus 0.1267 plus 0.0634. Let me double check those before I hit enter. Looks good. How about 0.8778, class? Okay, so the probability that somewhere from 7 to 12, believe the driving age should be raised is about 0.8778. Now, the other way that we did that problem in class the other day, you remember I drew a number line to try to illustrate it. If 7 is here and 12 is here, if we took all the way from 0 to 12 and then subtracted out from 0 to 6, that'd have to leave me 7 through 12. It'd have to leave me this piece. So if you understood that, then here's a quicker way to work that problem. You could do binomial CDF. We could add up all the way through 12, 15, comma, 0.6, comma, 12. So that's going to give me 0 through 12. And then I'll subtract out from 0 through 6 by going binom CDF 15, comma, 0.6, comma, 6. So again, I'm going all the way through 12, then I'm subtracting up through 6. So it should leave me 7 through 12, and there's the same number, 0.778. So that's the fast and efficient way. Some people that doesn't set in their head well. So if you want, you can do it either way, and one way is just a little faster than the other. Okay, so do you then have anything we need to go back and answer questions on from the homework from 6.2, which will be similar to this problem that we just worked? This is the kind of stuff you're going to see on your test, A, B, C, and D here.
I had a question on 35D.
Okay, 35D. Okay, 35D is just like the problem that we just did. It says find and interpret. Don't worry about the interpret part. The probability that between 8 and 10 flights inclusive are on time.
I'm sorry to interrupt. I said D.
Oh, no, don't be sorry to interrupt. Okay, that says at least 10 flights. Okay. Well, here's how I would think about that problem. If I was looking for the probability of at least 10, again, if I drew a number line, what do we got here? 15 flights. So here's 0, and here's 15. So at least 10 could mean 10, 11, 12, 13, or 14. It'd be this piece of the pie here. So I'd have to add up all 6 of these. Or I could take 1 minus 0 through 9. Does that make sense, Tommy?
Yes.
Okay. So let's do that. So go 1 minus binom CDF. Okay, and on that problem, we were talking about 15 flights again. So it's 15 and 0.8, and we're going up through 9. So how about 0.9384? Is that okay?
Yes, sir. Sorry, I was trying to do it with you.
No, you're good. Okay, so let's talk about the review problems you need to work on from chapter 6. Right quick. So make sure from page 355 you know how to do problems 2, 3, 6, and 7 are just alike. If you see an at least one problem on some of those, don't worry about it, because I told you we're not going to mess with an at least one. Okay, so we've got a couple little discussions to have. I need you all to unmute yourself for these, unless you've just got a lot going on in your house and there's a lot of background noise. But otherwise, I need you to unmute so I can hear your comments, because I want to get your all's take on this. Can I take this off the screen now? Okay. All right, so really we got a decision to make and then a conversation to have. Let's have the conversation first. So in the email I sent out, I told you that I'm not going to collect any homework. And I said last time I was worried about trying to get everything in, somehow get it graded and get it back to you. Someone in the class sent me an email asking me to maybe reconsider that, and said that there had been conversation with a couple of the others of you, and maybe some of the others of you agreed to that. So here's what I wrote back in that email. Let's get through this project first and see how that goes. Okay, so let's see how that is, me getting that in. If I grade it, I'm probably going to try to return it to you. So I'm going to get that in. I'm going to try to mark on it somehow and get it back to you. Let's see how that goes. And if that goes well, then I might reconsider the homework question if all of you, or at least a vast majority of you, agree to that. So that's a conversation we might circle back to. If it's like half and half, we probably won't pick it up. If like 90% or 80% of you want to do it, and I find that it's not that as bad as I'm hoping, or not hoping, but fearing, then we might try it. So I'm making no commitment on that. I'm just telling you I might reconsider later. Okay, so is it making sense what I'm saying to you right now?
Mm-hmm.
Yeah.
Part of the advice we got on going online was to keep it as simple as possible. Okay, so that was part of my thought in that decision starting off. Okay, the second thing I want to talk to you about is really two things. Remember the other day I said that for the test, we're going to need you dialed in to the class meeting. So the recording doesn't do you any good then. So we're going to take the test at one time. So everybody get on at 9 o'clock on Friday. And then I think I showed you this the other day, but here's what the idea behind the test. I want to see your hands. So you might practice this later today or something, but you want to adjust your laptop or your device to where I can see your hands, but you can still see your screen. Now I've trialed this with people who had laptops. I've tried it with people who had iPads, and I even tried it with someone who had an iPhone. And all three were still able to be able to see their screen and me see their hands. The screen's a little weird. It's tilted. So, I mean, I might see you do this once in a while, scroll down on a problem. I might see you maybe adjust your screen long enough to write a problem down. Okay, but even there with my adjusted screen, I can still see my hands. But your hands are what I need to see during the test. So I need all of you showing video when we do the test. So a little reminder on that, how we're going to approach that. And then the final thing is, let's make a decision about this test. So I've been telling you it's Friday, but it's been a long time. You know, we've only had a couple days back, and now we got a test. So I want to do what you guys are most comfortable with. So are you more comfortable with going ahead and taking the test Friday? Or do you want to maybe cover chapter 7, section 2 Friday and give you a little more time on the review and then have the test Monday? So who wants to speak in favor of having the test Friday first? Lauren, put his thumb. Boy, Tommy, you got something to say here.
No, I'm in favor.
You're in
I
favor.
don't want the slate to be wiped clean.
Okay. Who's in favor of having the test on Monday? This would be your time to speak. Okay, I'm seeing no one. So let's just, does anyone have any comment either direction? I think Friday's better. I think Monday's better. And here's why.
I think Friday's better. I don't like to start something new while we're still trying to learn something else.
I agree.
Okay. I'm going to close discussion on the count of 3, unless somebody interrupts me here. 1, 2. Oh, I'm getting a chat. Getting a chat. Let me get the chat up. Someone has said Monday is better. I would like more time to study this lesson. Okay, so we've had 2 comments in favor and 1 against. Okay, let's put it up to a vote. So, Jaden, if you're there, I can't see you, so you're going to have to vote by raising your hand through Zoom. The rest of you I can see, so you can just raise your hand. So how many are in favor of having the test Friday? Ready, set, go. 1, 2, 3, 4, 5, 6, 7, 8, 9. How many of you, 10, how many of you are in favor of having the test Monday? Raise your hand now. Okay, looks like we're going to go ahead and have a test Friday. Okay, so it'd be better, probably want to try to get on about 5 till on Monday so that when 9 o'clock hits, we can start straight away. So here's what I'm thinking. Like I said, I'm going to email you guys your test. You'll have to open up your email along with Zoom, and the test will be attached. So you'll have to open the test up. Can all of you open a Word document, or do I need to save it as a PDF maybe? Maybe a PDF will work better if you're trying to use your phone or an iPad. Okay, so maybe I'll try to do a PDF. Go ahead, Savannah. Oh, Savannah, did you have something? No? Okay.
No, I just bumped.
I got you.
Mr. Black, for
Hang on.
students with
Let me finish my
limited,
thought, Tommy, and then I'll come back to you because it's all rattling around in here. So then everybody will sit for the duration of the test. Make sure I can see your hands. So even when you're done, I'll probably have you sitting there for the duration. And then when the testing time is over, all of us will take pictures of our test, attach them to an email and send back to me. And I'll give you like 3 minutes to get that done. In other words, I want it done immediately. I don't want the test later that day, obviously, for obvious reasons. So that's kind of what I'm thinking. Okay, Tommy, sorry I cut you off there.
no, it's okay. For students with limited internet access, the school has actually purchased jetpacks, and those are in today for anybody that might need those. We're just
Thank
supposed
you.
to.
And did you all get the email on how to pick those up? Okay, so don't roll your window down.
I'm wondering how I'm going to do that with tinted windows.
Yeah, that's a good question. Maybe I have to do it out the front window. Okay, well, hey, thanks, and I'll see you all Friday. And listen, whatever you have trouble with on that review, shoot me an email, give me a call, whatever, and we'll try to get you some help on it, okay? All right. I'm going to leave the meeting unless somebody stops me here. All right, have a good day. Thank you.
Bye.